Lesson 9 is going to be about system of equations. Remember, a system of equations is just a set of two equations with a single solution. For this first example, it says, what is the coordinates of the point of intersection or the solution to the system of equations y equals x plus 4 and y equals 4x minus 5? So one of the things you can do when you have two statements that are set up as y equals, then we can write it as y stuff is equal to y stuff. Solve the equation. Plus 5 plus 5 x plus 9 is equal to 4x. Subtract an x, 9 is equal to 3x. Divided by 3, 3 is equal to x. So quickly we're going to look at our solutions. The only solution where x is 3 is a solution is answer B. But just to confirm, in case we had different, you would take this x value, substitute it back into one of the equations. 3 plus 4 gives us the 7 that's in that solution. For this particular example, if we're going to solve this system of equations, because they have one of the equations solved for a letter y, we can substitute that in where there is a y. So this is actually going to be 3x plus 2. Now, instead of writing y, we're going to write this expression that has only x. So we have one letter to solve for. 5 plus x is equal to 20. Distribute out, we have 3x plus 10 plus 2x is equal to 20. 3 plus 2 is 5x plus 10 is equal to 20. Minus 10 minus 10, 5x is equal to 10. Divide by 5, divide by 5, x is equal to 2. So part of our solution is x equals 2. Now, if x is equal to 2, we can figure out y by saying y is equal to 5 plus our x. Well, our x is 2, 5 plus 2 is 7. Our y solution is 7. So the solution to the system of equations is 2, 7. This second one I'm going to set up, but I won't go all the way through for solving. It says an ice cream parlor sells ice cream cones for $4, milkshakes for $2. If you and your friends pull your money to buy 7 items and only spent $20, how many milkshakes did you buy? So we have 4 per milkshake and 2. We have 4 per ice cream cone and 2 per milkshake is going to equal the total money. Now that money is consisting of cones and milkshakes per 7 items. We can then combine equations to determine the solution, but I'll let you know that there are 4 milkshakes in our solution and 3 ice cream cones. This next example, to solve this system of equations, you're now talking about having to combine equations. So if you multiply this whole equation, the top equation, by 3, that's going to give us an equation to work with. 3x plus 3y is equal to 30. When you add these equations together now, 5x, our y's being opposites of each other, 0 pair out, and that's going to equal 35. Divide by 5, divide by 5, and our x part of our solution is equal to 7. Now if I go back up to that original problem, it says x plus, correction, because x is 7, we're going to say 7 plus y is equal to 10, which means y has to be 3. And so our solution is 7, 3. This problem works almost the same way. Now, One thing to note here is if you ever have the exact same equations, and if you multiply this equation times 3, it's going to give you 9x plus 12y equals 6. Well, these are exactly the same equations. And so anything you multiply by is just going to cancel out. And so there are infinitely many solutions because the two lines are exactly identical, meaning they cross everywhere. And then in this example, almost the same way, but if you multiply this equation by 3, you're going to get 3x, 3y, and 6. Well, this equation is going to have no solutions because 3x plus 3y equals 6 and 3x plus 3y equals 3. There's not a common x and y term, so this is no solution. So if you have a situation where you get a statement that's not true, as this would be, then there's going to be no solution to that problem. Each of these following examples are going to work the same way, so I'm not going to talk you through each of them. But you can see the solutions to them. And that is the end of Lesson 8.